In this lesson, we're going to be discussing work, energy, and power. So let's start with work. What is work? Now, work is applied to any form of activity that requires the exertion of physical or mental effort. For example, if you are doing dishes, you are doing work. If you are cleaning your houses, you're also doing work. And if you're washing clothes, you're also doing work. However, in physics, we'll be discussing work done. Now, what is work done? Work is said to be done each time a force causes a displacement in the direction of the applied force. So let's take this Mr. A for example. This Mr. A. Now this Mr. A lifts this load of 1 kg from the ground up to this height, which are labeled as H. Now this is 1 kg. Now this Mr. A lifts this load from this point A to point B, or rather point A to point B. So this man has done a work against gravity because remember gravity pulls an object down. So by lifting this load from this point A to point B, this man has done work against gravity and also against the weight of this object. So in this case, the work done is equal to force times distance. Now, the force is equivalent to mass of the object times acceleration due to gravity, then multiply by. Now, in this case, the distance moved is above the ground level, and that's why we label it as h. So we're going to replace this d here with h, so which gives us this final equation of this work done as mgh. Now, by lifting this load of 1 kg, this man applied a force that is moving upwards. So this is force that this man applied, and then this force that this man applied on this 1 kg load caused a displacement in the direction of this applied force. The displacement is caused is this h that I labeled here. So that is the displacement is caused for this object to be moved from this point to this point. So work done is when a force applied to an object causes it to move in the direction of that force that is applied to that object by the person that's doing the work. So let's take another example. Let's come to this Mr. B. So this Mr. B pushes this 1 kg of block from say point A to point B. So he applied a force and pushes it to the right. So this is our force here, and so by pushing it, it causes a displacement. All right, so displacement is the distance between this 1 kg object at this point A and then at this point B. So let me call it x, or rather let me call it the distance. So he applied a force to this right hand direction. Another force he applied on the object causes the object to move in the same direction, all right, which is this d. So the work done by this Mr. B is given by work done is equal to, now the force that this man applied on this object multiplied by the distance that is caused by this force on the object. So here force again is equal to mass times acceleration due to gravity, and then the distance here is the displacement is caused, which is equal to d. Let me come back to this Mr. A. Now, assuming this Mr. A lifted this load from this point A to point B, and then after lifting this load, he kept on suspending this load for quite a while, let's say for about 30 minutes or 1 hour. So keep in mind that by suspending this block on the air, this Mr. A is not doing any work again. Why? Because he's not moving forward, backward. He's not lifting this load again or bringing it down. He just suspended it. And for work to be done, the force must cause a displacement in the direction of the applied force. So this Mr. A is holding or suspending this load to this height. As he's not lifting it up or bringing it down again, he's no more doing any work unless he moves it up or brings it down. That's when he does work. All right, so let's discuss energy. Energy is the ability or capability to do work. So it means that anything that does work possesses an energy. And so for the purpose of this study, we're going to be looking at potential energy, and then kinetic energy. We are going to be looking at these two forms of energy. And so what's potential energy? Let's start with potential energy. Now, potential energy is simply stored energy or the energy possessed by a body by virtue of its position or state. For example, we have magnetic potential energy, and this is a magnet at rest in its magnetic field. We also have electrical potential energy, and this is an electric charge that is at rest in an electric field. And then we have number 3 is elastic potential energy. There's a coil spring when stretched or compressed. Let me write it as elastic, then potential energy. And then last we have chemical potential energy. And this is released when petrol and other fuel sources are burned. And the formula for this potential energy is given by mass of the body times acceleration due to gravity, and then times height, where mass is in kilogram, acceleration due to gravity is in meter per second square, and then height is in meters. These are the base units of these parameters. And so the units of this potential energy, let me write it as EP, is given by joules, and same is applicable to the unit of work. The unit of work is also in joules. So let's discuss kinetic energy. Now, kinetic energy is given by the energy of a body by the virtue of its motion. And by its motion, it means that the body must be moving in order to possess this kinetic energy. And the formula is given by half times mass of the body times velocity of the body square, where m is the mass of the body and unit is kilogram, and then v is the velocity of the body or the object, and the unit is meter per second. Now, the unit of this kinetic energy is still in joules. The unit is still in joules, like potential energy and work. So all of them are in joules. So let's discuss power. So please, if you have not subscribed, please support me by subscribing. Thank you. Now, power is defined as the time rate of doing work, and so by formula is given as work done over time taken to do the work. Now let's assume that you are doing dishes, and for you to get the power you expended in doing that work, in doing those dishes, you are going to calculate your work done by calculating the mass times acceleration to gravity times distance, or however the case may be, then over the time taken to do such work. So that is the time rate of doing that work. That is power. And so the unit of this power is given as watt. And so this watt, by now this thing, now you remember this formula is work done over time taken. So it means that 1 watt is equals to 1. Now work done is in joules, and then time taken, the unit is seconds. So it means that 1 watt is equal to joules per second. Now you may be asked which of these units is equivalent to work. You may be given joules square per second, joules seconds, joules per second square, and then the rest of them, and also joules per second. So I want to know that joules per second is equivalent to watt. So 1 watt is equal to joules per second. In the next lesson, we're going to be solving numerical questions on work, energy, and power. Please don't forget to share, like, comment, subscribe, and when you subscribe, please remember to turn on the post notification bell so that each time I post a new video, you'll be the first to watch it. Thank you for engaging. Thank you for watching.